Put an elephant and a tiny ant on a scale, and you have two animals. But if you combine them as one unit of weight, the math breaks down completely because their masses are too different to add together. Ancient Indian mathematicians solved this by defining a complete, unbroken whole as rūpa. When we add identical wholes, like one pizza plus another identical pizza, the calculation is simple. 1 plus 1 equals 2. This logic also applies to parts of a whole. If you take a pizza, slice it into 4 equal quarters, and push those quarters back together, they recreate the original whole because every slice is the same size. This is a requirement for all addition. To combine any two values, they must be measured in units of the exact same size. The problem arises when wholes are cut differently. With 1/4 of a pizza and 1/5, you can no longer simply count the slices. Because they are different sizes, merging them results in jagged edges. They are dissimilar quantities, impossible to add directly. A common mistake is to add the top and bottom numbers straight across to get 2/9. But looking at the slices, we can see that 2/9 is actually smaller than our original quarter piece. The math doesn't match the physical reality. We cannot perform addition until we find a way to make these mismatched pieces share the exact same physical footprint. The ancient solution is savarnīkarana, making things of the same kind. We cut existing slices into smaller, equal fragments. Look at the 1/4 slice. Dividing it into 5 smaller slivers doesn't change the total amount of pizza. It just changes how we count it. We do the opposite to the 1/5 slice, dividing it into 4 slivers. Both pizzas now have 20 slices. To keep the value the same, whatever we do to the bottom, we do to the top. The physical size hasn't changed, just the grid. Let's try it. Pause the video and determine the common denominator for 1/2 plus 1/3. 1/2 becomes 3/6 and 1/3 becomes 2/6. Because the pieces are identical in size, we add them to get 5/6. Subtraction works the same way. Once the pieces are equal, taking 4/20 away from 5/20 leaves us with exactly 1/20. Creating a common denominator provides a single unit of measurement. It allows us to count pieces that were previously impossible to compare. This logic scales far beyond the kitchen. In science, when we measure microscopic particles or massive distances, we have to divide our units into millions of pieces to stay accurate. This diagram shows 250,000 over 1 million. To handle these huge denominators, scientists use scientific notation. This collapses those long strings of zeros into exponents, making the fraction much easier to read without changing its value. Even though the numbers look complex, the logic is the same. This massive fraction simply represents 1/4 of a whole. Here are the 3 steps for fraction arithmetic. First, ensure the pieces are the same size. Second, multiply the top and bottom equally to keep the fraction's value. Third, add the tops while keeping the bottom. The formula at the bottom shows this sequence in algebraic form. Take a screenshot of this cheat sheet now to use as a reference for your future problems. Arithmetic is ultimately a system for counting parts. Once you use a common denominator to ensure your pieces match, fractions are as simple to manage as whole numbers.